Good morning. I recorded this video last week and I just now discovered that it didn't make it to the video server. There's just been lots of things going on and I um, apologize for that. But I'm going to record it again, and since I'm going to be working out of the office for this next week, my videos will have to be parsed on my laptop and then just uploaded on the assignment link because I cannot connect to the video server without being there on campus. So Chapter 8 is all about cryptonology, and it begins with a timeline dating back to 1900 BC. And it goes forward through 2000. One of the things that worried me about this chapter, and some of you have shared with me that you're not really crazy about this book, but why is that stop 15 years ago? I don't understand why they did not update that particular table of history because common sense tells us all that there's been a lot of advancements in the last 15 years, and maybe the authors were hoping to just put that in the rest of the chapter, the advances that has been going on the last 15 years since they did that history timeline. But I was just, when I was reading over that history timeline, I thought, why did that stop right there? But anyway, this chapter is the history, the principles, the operating principles for most of the tools that are out there, the major protocols to do the secure locations. And you network guys, when you've completed this assignment for Chapter 8, and most of you have, you've shown me that you understand the secure socket layer and where everything happens in the networking model. We look at the science of encryption and how all of the different keys work and how it involves cracking and breaking into encrypted messages. And so encryption and then the decryption of those messages. Um, all of the web browsers use built-in encryption. Um, It says the restrictions on the export of those systems began after World War II. The cipher methods, and I hope that's what's coming up next, because that's what I was just strolling back through the book. All of these terms that are listed here are on page 422 of your book, the logarithm, and we know that that's a step by step. And in the assignment, I ask you to explain the difference between a bit stream, where it is done bit by bit rather than a block, where that it's done in the entire block. So all of these these definitions are on that page. I think most of us that are computer science technology majors have a pretty good logical working knowledge of encryption and how it works. So I very well remember doing this, and I'm going to go fairly fast because there's 44 slides, and when I have to parse on my laptop, it takes quite a bit of time. And right here in the PowerPoint is the answer to a couple of those things on the assignment for this, and I'm sorry that keeps popping up. It does it because of the way the video thing works, and I have not taken the time just to take that off. So the message is divided up into blocks, and each one of those blocks then are encrypted by bit and the logarithm. Um, so substitution, I don't know if most of you are guys in this class. There's one or two girls, but most of you are guys, and that's true of all CS classes that I usually teach. There's a very small percentage of women in technology, and that hasn't changed a whole lot since I've been teaching the last 20 years. when I was in grade school, we used this. You know, me and my friends would say, okay, the star is this letter, and the heart means this, and we sent each other messages that if anybody found our scrap pieces of notes, like the classroom teacher, they wouldn't be able to read what we said, and that was my beginning. And when I read this chapter, I thought, I done that a long time ago. Okay, so the substitution, where it uses one or more alphabets to do that. The mono uses just one, and I'm not going to attempt. My southern language has a hard time with words. Vinegar, is that correct? Uses a poly alphabet made up of 26 distinct alphabets. And if you'll look on page 423 in the book, okay, if you'll look on page 423 in the book, it gives you an example of this and how the alphabet is used and how that code or that text or that data is changed based on the alphabet. And you'll see that it just starts at the alphabet in different places in those 26 characters. And that's pretty neat, actually. Um, uh, I was trying to think of another way that I have used it. I've used this in other ways in the past, maybe by puzzles and different things to make it logical, like this. And that's showing you how that the alphabet is just started in a different place as it goes through the message. The transposition is simple to understand. You just rearrange it in different, like start from back to front or something like that, or start in the middle and go forward, or start in the middle and go back. Exclusive or XOR, the functions of Boolean algebra. And when you take C++ programming, you learn that all if statements and loops are written in a Boolean way, so that you're comparing two different things to decide what to do next. And this is exactly what that is. And there's a really good example of that in the book when you look at it actually gives you, and I haven't taken my pen to do that, on page 427, where you do the substitution there for the different things, for the different actual data bits. As in always, the person reading it would have to know that. It's it's simple to implement, simple to break. It is not really a way to encrypt messages that are going to transfer over the internet. So a little bit at the XOR table. So we're only looking at bits, zeros and ones, to see what the results of those are with the transposition. This one, developed at Bell Labs, uses a set of characters once per encryption process to change the values that need to be, the plain text to be encrypted. Uh, each character is turned into a number and a pad value for that position. The resulting sum then is converted back to ciphertext for transmission. The sum of the two values, if it exceeds 26, then 26 is subtracted from the total. And that shows you how to do that on 428, 429, goes into 430 on that section. Um, Book-based, the book one, the running key, and the template. Um, I I know I don't want to take up. I'm going to pause just for a minute. I want to do a Google to see how much it's used. Now, just a quick Google search shows that there is a company called CyberShed. There's one for SQL Cyber. So there are software out there based on what we're doing in this section. So book-based uses text in a book as a key to decrypt a message. There's a book cipher, running total, and then a template. Um, That's pretty neat, actually. It's similar, but not the same as the gear one. Neat. There are examples. Um, in the book of the different kinds. The template is a hidden message in a book, letter, or other messages. And we've already seen that where something is hidden inside of a document. And you see that in web pages. You know, that's how web bugs work. There's a GIF, an image that is built, that is loaded into a web page that is not seen by the eye, but that GIF is tracking the sites that you go to. It tracks how long you're there and all that kind of stuff. So hidden messages and how they work. Then next are the hash functions, the math logarithms to change your message. The Mac machines use those. And I have seen hash functions used in lots of areas in programming, and here we see them used to change the data. Two broad categories of cryptographic logarithms. And just in your mind, a logarithm is a step-by-step process to solve something. So there's symmetric and asymmetric, again, real-time and not real-time for those. When you look at our book, you see that there is a hash calculation example on page 433. And then when you get to this portion, there is the technical details of how encryption works and decryption in this, and then how the keys come into play in this section. So requires a secret key, the same secret key for the symmetric, known as private key encryption. And it gives you a look at how that actually works from one person to the sender to the receiver. Less data encryption standards. It's one of the most popular. It's a 64-bit. So it has a 56-bit key adopted by NIST and 76. Let's do a quick Google and I'll pause and come right back in this area. Okay, you can see what I Googled. I wanted to see which is the most secure. And then actually the first site that hit me was that it's almost dead. Is encryption almost dead? 11 reasons why. InfoWorld really does have some good articles. And then this site shows us, and now this talks about government security, but it's not a government site. It's a nonprofit organization, which encryption is the strongest and the most secure. And then there's 5 common ones. So I will load these in the class so that you can see and read further if you want to. This is something that you're going to see over and over in the in your cybersecurity track. More about security, and you will, as Mr. Randall told me, you will get a chance to do this firsthand in some of the other classes. So I wanted to put that one there. I went too far back. Okay, here. And then the 5 most common and which are good. I don't really know that site, but I do want us to go, would ask you to take a look at that. What are the unbreakables of the future? And maybe that connects with the info world, you know, that basic encryption as we know it now is going to advance. I was hoping the FBI guy would talk a lot about this in his speech yesterday. And by the way, not to get off the subject, but I have just loaded. If you go to this site, you can have a video of all of the speakers yesterday at the conference. Now, some of it may not mean a whole lot to you. Dr. Brancha talked about a program, actually a training seminar that's going to be available for teachers to make sure we have good material in our classes. So that's really aimed at teachers. But I hope you'll take a look at some of those. The FBI guy wanted to stress social media. And he talks about even if you are not a social media person, it affects you. I have always been amazed at the amount of private information people are willing to share about themselves online. So if you get a chance, take a look at those too. Okay. It keeps asking me. That's usually why I just close it. So take a look and see which one of these are used the most in the workplace, and you'll find which one popular software out there, which ones are being used the most. In searches like that, I usually put things like what has the market share. Then asymmetric, those were symmetric. Asymmetric has two different keys. It has a key A to encrypt the message and a key B to decrypt the message. The asymmetric encryption begins on 437 in our book, and there's a technical details of how that actually works. When we look at the pictorial showing us from sender to receiver how that works, sending the private key with it, and then the public key. The private key decrypts the message, the public key encrypts the message back. So the key size is important, and you can see that it's like a 32-bit is not as secure as a 64-bit, and how that works. Please look at this table. This is pretty neat, and it shows you the size of the key link, how long it would actually take to decrypt the messages if they get bigger than 64. Now it takes 2.74 years on a 64-bit. How many years? 500,000 years. So you see that the keys really do matter in this. I love it. How to use it for sensitive messages, how to make sure the identities of the senders are not there, and really that's what has to happen in an online buying environment. That all of that stuff has to be encrypted as you shop from one form to the other, adding tax and all that stuff. It has to be encrypted and be encrypted soundly, because you don't hear very much hacking going on right during an online purchase. So there is descriptions then. Uh, a public key that you have a certificate authority and a registration authority. Let me just stop again and pause again. Okay, my search just came up with what I really wanted to see. Who is the largest SSL certificate authority in the world? Then others, let's see. This one has been here. Now, it used to be called VeriSign, but Matic bought it out. It used to be called VeriSign. And when you're buying something online, if you will scroll to the very bottom of your web page, when you're buying, it will tell you who the certificate authority is. And see, there's VeriSign. It's still used a lot, and you'll still see their logo, even though they've been bought out. They still do that. And I've been doing well since the late 90s. even before we had online course management systems, and VeriSign was there then. And, we've come a long way in the last 15 years because we didn't do a whole lot of online buying until the last 15 years, and now everybody doesn't even think anything about it. I'm going to go back now one more time and do registration authority. Okay, gives us a little bit of some legal things, insurance links. Let me just take that market thing out and just put RA here, and I believe we'll get different results. So that there shows you again that this company is still the leader in that. Gives you other, of course, others. There's the ISO standard for registration authority, and then lots of links then to public key infrastructure and how it's used in different platforms like Microsoft. If you're new to computers and Windows, the MSDN library is Microsoft's library. They also have a tech library now, but the MSDN library has been around since I've been teaching Visual Basic since 1996. It's just a full library. The thing that goes along with that is you have to sometimes search for what you're really trying to find, but it's a great technical library. So policies and procedures and management, I'm just going to keep on going. The digital signatures, there again, we just saw who is the authority in those and how it works. The certificates. If you will look on page 445 in your book, they're not really here it is. This is a pictorial of the encryption, the certificate purpose that you can add to your browser under your internet options. Now, if you use, not sure, this is Internet Explorer, but you would have the same thing. Most of us don't use Internet Explorer anymore. In fact, that's not even the browser that's being sent with us. This actually tells me how much this book needs to be updated. Most of us use Chrome or Firefox, but if you look under your internet options in either one of those browsers, you're going to find the same thing. There are lots of choices that we have in that internet options, and I hope this class has triggered you to look further into your browser at what you can decide as you go, as you search. The standard 509, discusses this structure, and it gives you the source right there for the network security. There are lots of companies that set computer and network and internet standards, and 504 is one of those. The IEEE is one, ISSO, of course, is one. W3C is the web authority setting the standards there. Lots of standards that you'll be exposed to in your computer science technology degree. Hybrid, except for the signatures, they're asymmetric. It's not widely used. This one, most common hybrid system, and it shows you that let me see. I'm trying to go as we go. It's 449 in our book. There, maybe I selected the right one. Okay, a look at the public key repository, just an example to show you how it works of a hybrid system. That's on 449 in your book, how it goes through the public key, and then it has a session key, and that session key is at the SSL layer. When you see that with the HTTPS when you're loading websites. It's secure hypertext protocol, and there's two of them. Let me see if that as I go forward. No, it didn't. There's two. There's uh, SH, the SHTTP protocol and the SSL protocol that's in the network, both of them in the network model. It talks about Netscape developing the secure socket layer. Netscape browsers are not used anymore, but that company still works in computers and security of the internet. And then there's the MIME, MIME, has been there forever. We used to use MIME email more than I see it now, but we did use it when I first started teaching, and that it saw it all the time where your messages were encrypted. I used to get a lot of my downloads from textbook publishers in that format that had to be decrypted when I got it back to my machine. Now look in your book on page 435, and I'm sorry, let's see, that term, some applications hide the messages. We see that in James Bond kind of things, and that CSI show that is cybersecurity. We see it on there. I've only got to watch it once. I can't watch very much TV. So the protocol. One of the things you want to make sure you understand in this word protocol, there is a standard for all things computers. There's a standard for all things networking. If you've taken the Intro to Networking class, you know that even encrypted the twisted pair wire, the 8 twisted pairs. There's a protocol for that, how that's loaded into the jack by colors, the RJ45 jack, how that's loaded in by colors. So, okay, this is the two that we were just talking about, the secure socket layer, and then the internet mail extensions for the MIME. That goes straight into the wireless technology. The wired equivalent privacy, the hi-fi that we are also comfortable with now, and then of course Bluetooth. And Bluetooth has kind of died down, but Bluetooth now is a standard for short range wireless communications between devices. I remember it being on Big Bang Theory and how everything was just better if it was Bluetooth. Then if you look, this is on 456 in their book, and there's a table with, let's see if they put it here. They did, sorry. There's the encryption that has been broken by scientists and hackers, right? Then there's the authentication that has been. So it talks about, it's comparing these two, WEP and WPA. There is more on that as you go through the text and read about those two particular standards. Securing TCP/IP with IPsec and PGP, beginning for that is on 450 and toward the very end of the chapter. The Diffie-Hellman key exchange for deriving the keys between peers. I know I don't have to do this, but just in case, there are basically two types, right, of network configs. Right, peer-to-peer, where there's no node that's in charge. Everybody is the same, right? And then the other one is client-server. And you know that from your other classes, I hope. And you may not have gotten those yet. Networks are configured those two ways. If you have to put in a user ID and a password, it's client-server, right? Napster made peer-to-peer popular. Now, that's what this is talking about. It's deriving keys between peers on a public network. On a public network, there's no network administrator putting in users with their ID and password and what roles and privileges those users have on the network. so everybody is just the same. Okay, and then let me increase that so it's more legible. This is talking about your packets as it goes across the network. There is a header with the information that goes in the header. If you don't understand this yet, you will once you have your intro to networking class. It does in that class. It tells you what's in the headers and then what's in the actual part of the message where the data is that's being transferred. The authentication that goes along with it and all of that. So if a message is large, and usually even a very small message takes more than one IP packet, as those packets flow, there's information bits there that actually connects the packets together. And the packets actually doesn't have to go all in one line. They can be mixed up in transit and go even different routes over different communication channels and then be put back together when they reach their location. So that's a look at what that's talking about. Pretty good privacy. Developed in '91, the best of the cryptographic logarithms. It become open source, and you know what that means is that open source is free to everybody, like the Linux, Unix operating systems. Open source can be modified if you know how to do that programming. Freeware available for many platforms. One of the things I talked about with Mr. Randall is um, we have software that has to run on particular operating systems, but our NetLab solves that. In NetLab, we can put it on Ubuntu if we want to. And that's what I do with the advanced web class. The beginning web class is in the spring, and then the advanced web class will come after that. We use Ubuntu because Ubuntu is used by a lot of companies. It's a wonderful operating system. It works well with PHP, the language that powers the internet, works well, of course, with Java is another language that powers the internet. So we do get a look at that. Now, if you look at the very last, that is explained carefully in the book. There may be another graphic here. No, there's a graphic in the book that shows you the logarithm, the function, the logarithm, and then the digital signature or the encryption, the compression as well that works with file management. It uses the ZIP compression, and I know you know that, but if you have one folder that has lots of files in it, you can compress that folder in the Windows operating system just with a send to and compression. You can compress it different ways, of course. If you use a Mac machine, that is a different file type, but the .zip compresses that folder. So encryption is not the same thing as compression, but a compression is always mentioned in a encryption where encryption is talked about. I'm going to close. I hope you have a good week. I'm going to parse this and put it up in the assignment link, and I will do chapter 9 just right back to back. And then I'm going to work on our exam for this section. I hate that my video was lost the first time I did this, and I hate that it's late. Have a good day.